Alright, 12.5, we're going to do an introduction to probability. 99% of this will be review type stuff because you've been doing this forever. Probability is a number between 0 and 1. That could be like 0.2 or 1/2 or 30%. All of those can represent a probability because they're all numbers that are between 0 and 1. Probability of 0 means that it cannot occur. It is completely impossible. It's like rolling a 7 on a die. Dice only have 1 through 6 on them, so you cannot roll a 7 on one of them. It's not going to happen. Probability of 1 is certain. It has to happen. There is no chance that it will not. Most things fall somewhere in between. Alright, so our probability of a random event occurring, then our number of outcomes divided by our total amount. It's kind of what you want to happen divided by the total amount of things that can happen. So if we want this to happen, our probability of it happening is going to equal how many different outcomes show it divided by the total amount of things that are there. So our probability of spinning a 5 here, there's 1 5, so that's a 1 out of how many total? 5 things, so that's our probability. A 1 or a 3, well that's a 1 or a 3, that's 2 parts out of still 5 total, and so forth. Even numbers, what do we have there? 2 and 4, so that's another 2 out of 5. And spinning a 6, well, is there a 6 on our spinner? No. So our probability of spinning a 6 has got to be 0. Alright, cards from a random deck. 52 cards in a deck. It's weird to me when kids don't understand how a deck of cards works. So here you go. Those are the 4 suits that you're going to find. Diamonds, hearts, spades, and clubs. So that means every 5 has every one of those suits, and a 6 has one in every suit. Together that makes 8 total cards that are going to be a 5 or a 6 out of 52 possibilities. Alright, so here we're in this situation, blah blah blah. Big thing is that the 919 here is going to be our total. What is it that we want? We want physics and philosophy. So we're going to add these two here together. What's that? 5, carry a 1, 3. So 435 means we're going to have 435 over 919, which, if you want to change that over, is going to be 0.473 and so forth. So 47%-ish. Alright, so here we're talking about a single die. You're going to roll it twice. How many numbers are on a die? 6. So we're going with 6 times 6 makes 36 different things that can happen when you roll your dice. Alright, how many different ways can we make a 5? So, or something that's less than 5, I'm sorry. You can roll a 1 and a 1, a 1 and a 2, a 2 and a 1, 2 and a 2, and what else? 3 and a 1, or a 1 and a 3. So that's a total of 6 different ways. So 6 out of 36 is 1/6. Alright, so here we're talking about a coin. We're going to toss a coin. What can you get? You can get a heads or you can get a tails. That's 2 choices times 2 choices means 4 different things that can happen. Heads, heads, tails, tails, heads, tails, or tails, heads. So there's 4 different things. What are the outcomes where you're going to have different outcome? 2 of these. So our probability is going to be 2 out of 4, 1/2, or 0.5, or 50%. That's the worst percentage sign I've ever done. Maybe. Alright. So what's our chance of getting a heads on the coin and a 6 on the die? Well, you're going to do both of those individually. So there's your chance of heads, there's your chance of getting the 6. Multiply them together, get your probability. Alright, so here we want to land on a red and a green. Well, here it says 3 of them are red. So we're going 3 out of our total of 6 times our green is going to be 2 so times 2, also out of 6, for a grand total of, well, I'm going to simplify these first and go with 1/2 times 1/3, which gives me 1/6. Alright, this time we're going to go 3 times. We want to get a green every time. So was our green 2 out of 6, which was the same thing as 1/3. So we got 1/3 times 1/3 times 1/3, which is going to be 1 out of 27. Not very likely you're going to spin a green 3 times in a row. Alright, so this time we're talking about, you dealt 1 card, you're going to replace it. This is the big deal here. Replace means you're going to put it back in, means we're always going to have 52 as our total. Then we're going to draw again. What's the probability of getting a queen and then a picture card? Picture cards are the ones that have faces on them. So those are jacks, queens, and kings. Well, there's 4 queens, and there are 12 of the others. Alright, so we're going to go with 4 out of 52 on our first chance of getting that queen, times 12 out of 52 for our second chance of getting the jack, queen, or king, our face cards. What's that gonna? That looks gross. Which, there, if you multiply it, 4 times 12 is 48, 52 times 52 is 2704. You can reduce your fraction, or you can just get 0.017. Either way, it's not very likely. Alright, we're going to toss a fair coin 3 times. What's the probability of getting tails? Tails is a 1 out of 2 chance. We're going to do that 3 times. Oh, just because it's 3 times and I'm even right 3. Oh, goodness. This went poorly. Let's try that again. 1 out of 2 for 1 tails. 1 out of 2 for another tails, and 1 out of 2 for another tails. That's going to be a 1 out of 8. I apologize. I feel like I always apologize on here. I think that's what I do. Alright, we got 32 rubber ducks. We're trying to get, what is it? Blue? Where'd it go? 2 blues without putting it back. That's the big thing here. So we got 12 blues out of 31. But then we're not going to put it back. So now we only have 11 blues out of 30. Well, that's crazy. And that's what you get multiplying your fractions and simplifying, or just getting your decimal there. Alright, and I swear we're almost done here. We got 3 sophomores, 8 juniors, and 7 seniors. That means our total is looking at 18 kids. With the probability of selecting a senior and then a sophomore to go on our trip. The thing here is that if we select a senior, which is going to be a 7 out of 18 chance, when we go to select our sophomore, there's still 3 sophomores, but now there's 1 less kid total, so it's out of 17. So that's going to get us, what, 21 over 306, and as a decimal it's 0.068. So apparently not very likely that you're going to pick a senior and then a sophomore. Mostly because there are not many sophomores in the group. And lastly here, we got red, we got black, we got white. 3 marbles are drawn without replacement. What expression is going to get that they're all red? Well, our red is 10. So we're definitely going to start out with 10, but our reds are going to go down, so it's not going to stay at 10 because we're not replacing them. Now, these ones are both going down, but also this one, our total number is not going down. That ain't right. Our total number has to go down as well if we're not putting the marble back. So D is our correct answer, and we're done in less than 10 minutes with a review of probabilities. Make some good choices. One more section to go.